We spend like our entire lives looking at screens.
Oh, absolutely.
And we have this baseline assumption, this almost invisible contract, that what the screen tells us is reality. I mean, if it says there's a software update, there's an update. If a login box pops up, well, it's because our session timed out.
Right. It's a very clean binary relationship.
Exactly.
It is a deeply conditioned response. I mean,
Yeah.
we have been trained for decades to rely on those visual cues to navigate the digital world safely. The interface is our only window into the machine, so we just trust it inherently.
But what happens when that contract is completely rewritten? When the screen itself, the very interface you trust, becomes the ultimate weapon?
Yeah, that's when things get dangerous.
Today, we are taking a deep dive into a massive stack of recent threat intelligence reports and vulnerability disclosures. Our mission for you, the listener, is to cut through this dizzying noise of modern cyber threats and, extract those critical aha moments.
Right, because there's a lot of noise out there right now.
So much noise. We want to understand how attackers are upgrading their operations and what it actually means for digital trust. So let's jump straight into this first report because it completely turns that invisible contract on its head.
It really does.
We are looking at an evolution of a long-running North Korean campaign. It's known as Contagious Interview, or UNC 5342. But they've actually dropped the fake job offer.
Yeah, they've pivoted entirely.
It now starts with an entirely innocuous web search. In one highlighted case, a victim simply searched for electrophoresis machines, literally just lab equipment, and clicked a sponsored result.
And the moment that seemingly harmless page loads, the trap springs.
Oh.
The browser displays a full-screen, highly realistic, fake macOS reboot or update message.
Wow.
It essentially locks the visual field completely.
The report from AllSecure specifically notes that this experience is designed to induce sheer panic, right? The computer appears completely frozen. So the user, thinking their operating system has catastrophically crashed, suddenly follows instructions they would normally spot as a massive red flag. The fake page tells them they need to open their terminal app and paste a command to fix the error.
But what the victim doesn't realize is that the malicious page has already stealthily copied that command to their clipboard.
Wait, like the second they interacted with the page?
Exactly, just from that initial click. This technique is called click fix. The mechanics of the payload they paste are actually brilliant in their evasiveness. It's a curl command that fetches a Node.js backdoor.
Okay.
But this entire sequence is single use. If a security researcher tries to replicate that exact sequence like 5 minutes later, the malicious server just ignores them.
That's incredibly frustrating for defenders, I bet.
Oh, absolutely. And once that initial backdoor is established on the victim's machine, it silently fetches a malicious Chrome extension and an information stealer.
And the stealer is designed to target, 157 different cryptocurrency wallets?
Yeah, 157 different wallets.
See, I have to pause and push back on the logic here because this seems so convoluted.
How so?
Well, the attackers are going through this elaborate theater of a fake full-screen update, right? Relying entirely on the user to manually open a terminal and paste a command. If these are sophisticated North Korean actors, why not just exploit a browser vulnerability silently in the background?
Yeah, it's a good question.
I mean, why make the user do the dirty work?
It comes down to basic economics, really.
Oh, yeah.
And modern defense mechanisms.
Yeah.
Zero-day browser exploits are incredibly expensive to develop.
Right.
They often cost millions on the black market, and they get patched almost immediately once discovered. But human psychology,
Yeah.
that is completely free. And you can't issue a software patch for panic.
That is a terrifying point.
Plus, modern endpoint detection systems are incredibly good at spotting memory corruption or background exploits executed by a browser. But when a user manually opens a terminal and pastes a command...
The system just trusts it.
Exactly. The operating system sees that as a legitimate, user-authorized administrative action. The attacker is weaponizing your own system authority against you.
It's like a burglar knocking on your front door dressed as a firefighter, telling you your house is on fire and then handing you a lit match to hold.
That is the perfect way to look at it.
You are the one doing the damage because you think you're fixing a crisis.
Exactly. And because it works so well, the tactic is adapting rapidly across different operating systems. Like, Cyberproof tracked a Windows variant of ClickFix where victims are tricked into pasting a command into the Windows Run dialog.
And what does that one do?
That command communicates with an external WebDV endpoint. It uses a legitimate Windows tool, rundle32.exe, to load the malware. But here is the trick. It calls the malicious function by ordinal number 1.
Okay, ordinal number one. I'm assuming this is a way to hide from command line logs, but how does that actually work mechanically?
So think of a piece of software, like a sports team. Normally, if a security scanner is looking for a malicious function, it looks for the player's name on the back of the jersey, something like run malware.
Right.
Calling by an ordinal means the attacker is calling the player's jersey number, say, player number 1.
Yep.
The security scanner is looking for the specific text string of the malicious function, but it only sees a generic number.
Oh, that's clever.
It is.
Okay.
By doing this, it loads a memory-only payload, something like a file named gc.key, without leaving any recognizable artifacts or actual files on the hard drive.
And it's not just these fake system updates driving this either. The Huntress report in our stack highlights something called the MacSync stealer.
Yeah, that one is fascinating.
Victims searching for how to install Claude AI on a Mac get served a sponsored result that looks exactly like an Apple support install guide. It even points to a weaponized Claude.iShare conversation to look authentic.
And the technical depth there is wild.
Mm-hmm.
It uses a dizzying 6-stage kill chain just to steal a single permission.
Just the macOS screen recording permission, right?
Exactly. Just to raid wallet apps.
So,
And there's also the relay malware, which masquerades as a fake AI meeting tool just to steal macOS and Windows credentials, keychain data, and Telegram sessions.
so the barrier to entry for the victim is getting lower, just clicking a search result. But the sophistication of the back-end infrastructure supporting these campaigns is scaling massively.
Massively.
And if the back-end is scaling, that means they aren't just manually setting up these servers anymore. Building on that North Korean crypto-stealing payload, the threat intelligence shows they are moving to industrialized operations using something called ether hiding.
Yes, ether hiding.
I'm looking at this, and it seems they're using the blockchain itself to hide their operations.
They are. Instead of using standard web servers for their command and control, which security companies can easily block or just take down, they're using Ethereum smart contracts as highly resilient command servers.
That's insane.
The infected machine actually polls the public blockchain to find out where to get its next set of instructions.
And the execution is completely industrialized. It's a literal assembly line. The attackers use a throwaway crypto wallet and fund it with a tiny amount, about 0.0126 Ethereum.
Right, just pennies.
They deploy the contract, write the configuration data into the blockchain to point to URLs like rg-telemetry.sbsupply or thudupdates.sbsanalytics. Then they forward the leftover fraction of a penny, about 0.006 Ethereum onward, to another wallet and abandon the first one.
Fund, deploy, configure, abandon, repeat.
It creates a supply chain of cybercrime that is virtually immune to traditional takedowns. I mean, you cannot simply unplug or censor the Ethereum blockchain.
You really can't. But as heavily automated as that ether hiding process is, we are seeing another leap forward in automation that is fundamentally paradigm shifting.
You're talking about the AI-enabled autonomous hackers.
Yes.
This part of the Unit 42 report is wild. They tracked a Chinese-speaking threat actor operating under aliases like Knife and Nguyen.
And this actor is using an AI model, DeepSeek, wrapped in a framework called Hermes Agent, to act as a completely autonomous offensive operator.
We really need to underline how critical a development this is. We aren't talking about humans using an AI chatbot to write a slightly better phishing email.
No, not at all.
The AI is operating through Telegram without any human intervention whatsoever.
The Hermes Agent gives the AI terminal access and command and control capabilities, while DeepSeek serves as the actual reasoning engine making decisions.
It's autonomously enumerating targets and scanning GitHub for trending proofs of concept. It prioritizes the attack surfaces on its own.
It really does.
The report caught it actively orchestrating attacks on 7 specific vulnerabilities. And it wasn't just hitting low-hanging fruit.
No, it was targeting enterprise-grade infrastructure.
Right. It went after Langflow, Citrix NetScaler, Apache Tomcat, Palo Alto Networks, PanOS.
Yeah, big targets.
And the list goes on. AnyNN, Marimo Notebook, Windows Ike extensions. It's doing all of this on its own. If a target environment is restrictive, the AI autonomously searches for new CVEs to try.
And the actor didn't just use DeepSeek either. They utilized Claude Code, Codex, and Quen Code. We see a similar operational scaling in Operation Standoff, orchestrated by a Russian-speaking group.
What's their methodology?
They combine a paper install loader delivering commodity malware stuff like Raccoon, Stealer, Redline, and Amity with a bespoke command console for hands-on keyboard intrusions.
Okay.
But then they layer on an AI-driven influence apparatus using vast networks of fake Telegram accounts to boost illegal gambling and fraud services. The entire operation is a blend of automated malware, human intrusion, and AI propaganda.
I have to stop here because this raises an incredibly pressing question for you.
Sure.
If AI is now autonomously hunting for vulnerabilities on GitHub, reading proofs of concept, and deploying exploits against corporate firewalls while we sleep,
So,
is the traditional human security analyst fundamentally outgunned?
honestly, yes.
What is the digital equivalent of a smoke detector for an AI intruder?
In terms of raw speed and scale, human analysts are absolutely outgunned. The smoke detector for an AI intruder has to shift entirely away from looking for known bad signatures.
Because the AI is constantly adapting.
Exactly. An AI reasoning engine that is dynamically chaining together novel exploits still has to traverse a network to find valuable data. It still has to establish persistence. The defense has to rely on AI-driven behavioral analytics to spot a machine moving laterally through a network in ways a human administrator simply never would.
Okay, so if AI is going to automate the exploitation of known vulnerabilities and ClickFix is bypassing human skepticism, you'd think the last line of defense is locking the front door with strong identities.
You would think so.
But threat actors are sidestepping the door entirely by compromising trusted partner networks.
This is arguably the most pervasive threat model today. Take the group Shiny Hunters.
Oh.
The Health ISAC recently warned that this group prioritizes identity compromise over deploying traditional ransomware. Their pattern is brilliantly simple. They use voice social engineering to call a help desk, pretend to be an employee, and trick the IT staff into resetting their multi-factor authentication.
And once they have that reset, they take over a Microsoft Entra or Okta single sign-on account, pivot into connected software as a service platforms, and rapidly exfiltrate massive amounts of data for extortion.
Exactly.
Using single sign-on as the main control plane is like giving someone a universal master key to your entire life. If an attacker tricks a locksmith into handing over a copy of that master key, they don't need to break a single window.
That is the grim reality of centralized identity. And we see this intense focus on identity and access, specifically targeting Russian and CIS organizations right now.
Oh, right, the report on Xbox 22?
Yes. That threat actor recently switched from using older tools like Formbook and Snake Keylogger to using Xworm. They are deploying a brutal Android Trojan called Lunaspy.
And that disguises itself as a mobile antivirus app, right?
It does. But it actually captures audio, camera feeds, and screens of Russian banking customers.
And it's not just internal identities, it's the trusted connections with external partners. There's an extortion group called Toy Ghouls, also known by aliases like Barelyify or Labubu, targeting the Russian manufacturing and finance sectors with a custom ransomware called Genie Locker.
That's a major one.
In a highlighted case, their initial access wasn't a zero-day exploit. It was an open VPN connection originating from an external partners network. They exploited that trusted relationship to breach the target, moving laterally using standard remote desktop protocols and SSH.
It's a huge problem.
I really struggle with this one. Aren't trusted third-party networks and external open VPN connections supposed to be heavily vetted? How do these supply chain connections remain such a glaring blind spot for enterprise security in 2026?
It largely comes down to configuration drift and implicit trust.
Configuration drift.
Yeah. Say two companies merge, or a vendor is given network access for a specific 6-month project. Project ends, but no one ever closes the VPN tunnel.
I see.
Security teams monitor their own public-facing perimeters fiercely, but they often treat traffic coming from a trusted partner with significantly less scrutiny. Attackers exploit that blind spot. Group IB detailed a covert Linux XMRig campaign first seen in March 2026 that did exactly this.
Right. They exploited a trusted third-party relationship to breach the network, and then they weaponized a specific Linux policy, the PAM-RUTOC policy, to seamlessly impersonate multiple low-privileged users.
Yes.
Let me see if I understand this mechanism. Pluggable Authentication Module, or PAM, is how Linux handles passwords. But what does the RUTOC part actually do that makes it so dangerous?
Right. By default, PAM-RUTOC is a convenience mechanism. It allows the root user, the ultimate administrator, to switch into any other user's account without having to type in a password.
Okay.
The attackers in this campaign weaponized that policy to jump seamlessly between various low-privileged service accounts.
So they're constantly changing disguises without ever hitting a password prompt.
Exactly. And because they controlled that authentication module, they created a forensic smokescreen. They actively disabled the logging services and removed authentication logs, creating redundant persistence across completely unmonitored accounts.
Wow.
Incident responders refer to this as a Hydra-like infection because you cut off one head, but they are already hiding in 3 other unmonitored accounts, completely invisible to standard file-based monitoring.
And we are seeing the massive consequences of these identity and access failures everywhere in the stack. Origin Energy recently reported a breach where attackers accessed the dates of birth, account details, and partial credit card numbers for 900,000 customers.
Massive scale.
And security researcher Eaton Zveer disclosed a terrifying vulnerability in November 2025 in My Azure, a fleet management system. Unauthenticated APIs allowed full account takeover.
Meaning someone could literally gain control of a company's entire physical fleet of hundreds of commercial vehicles.
Thankfully, that was fixed by November 20th. We are also seeing threat actors like CastleLoader or Noidret delivering the Needle Stealer framework, which includes a Rust desktop wallet spoofer and a Golang browser extension installer via digitally signed installers.
And that digital signature is just another form of abused trust. The operating system looks at the signature, verifies it belongs to a known developer, and trusts it. Consequently, the user trusts it.
Which transitions us to a critical realization. While a compromised identity or a fraudulently signed installer is incredibly damaging, there is a scale of vulnerability that makes individual passwords entirely irrelevant.
Oh, absolutely.
We need to look at foundational flaws in the platforms housing the data itself and how defenders are scrambling to respond. We need to talk about Cosmos Escape.
Right. Cosmos Escape is the name given by the security firm Wiz to a massive vulnerability they discovered in Azure Cosmos DB, which is Microsoft's globally distributed database service.
How does a database query break the cloud? What is the actual mechanism here?
So, Cosmos DB has a custom engine designed to translate specific types of queries, called gremlin queries, into .NET code to run safely inside a restricted sandbox. But Wiz found that the restrictions failed to account for a feature in the .NET framework called reflection.
Reflection, meaning the code can look at itself.
Think of it like a program looking into a mirror. Reflection allows code to examine and modify its own structure and behavior while it is running.
Oh, I see.
By crafting a highly specific query using reflection, the attacker's code could essentially step outside of the rules the sandbox was trying to enforce. It escaped the sandbox and achieved direct code execution on a component called a multi-tenant DB gateway.
And this DB gateway handles queries for multiple different customers across Azure Service Fabric clusters.
Yes, because the attacker had code execution on that shared gateway, they gained access to a signing secret that Wiz called the Cosmos Master Key, as well as a regional config store directory.
That sounds bad.
It was lethal.
Yeah.
It allowed them to retrieve the primary account key for any database across customer tenants. It didn't matter if you were running SQL, MongoDB, Cassandra, Gremlin databases. It completely bypassed all network isolation.
Wait, let me make sure I'm fully grasping the scale of this. A flaw in a specific graph database feature could have potentially allowed an attacker to read private Microsoft Teams messages and Copilot user conversation histories for completely unrelated companies hosted on the same platform.
Yes.
Because the Microsoft documentation shows that data is stored in Cosmos DB. That is absolutely terrifying.
It is the ultimate nightmare scenario for cloud architecture. To be entirely clear, Microsoft acted fast.
Good.
They blocked the vulnerable gremlin entry point within 48 hours of the November 2025 disclosure, and they completely eliminated that platform-wide master key architecture by July 2026.
Did they find any evidence of abuse?
They found no evidence of unauthorized customer access outside of Wiz's testing. It is also important to note this is entirely separate from the older Chaos DD and Cosmos flaws. But it forcefully highlights that even the most robust, globally relied upon cloud platforms have foundational seams.
But the defenders are fighting back, and they are doing it at an incredible scale. Look at GitHub's response in the stack.
Yeah, that was huge.
They just rolled out a massive 10-step supply chain hardening initiative. We are talking preventive account protection for high-impact NPM accounts, much safer pull request target defaults, read-only caches for untrusted actions triggers.
And official support for Circle CI.
Right. Staged publishing, default package cooldowns, and expanded credential revocation APIs. They are completely re-architecting the safety nets for developers.
We see that same massive scale in Google Chrome's recent patch drop. Version 151.0.7922.71 and 0.72 addressed a staggering 370 flaws. Yep. 7 of those were critical, specifically CDE 2026-17650 through 17656. What is truly notable is that nearly all of those 349, to be exact, were found by Google internally, using aggressive fuzzing tools like Address Sanitizer and libfuzzer.
That's proactive.
Extremely. They have addressed over 1,800 bugs this year alone. They are relentlessly hunting their own code.
And the UK National Cybersecurity Centre is publicly urging device manufacturers to drastically improve forensic observability on edge devices like firewalls and VPN gateways, so incident responders actually have the logs they need when a breach occurs.
The defenders are realizing that they can't just patch individual holes anymore. They have to change the topology of the battlefield, eliminating master keys, enforcing read-only environments demanding better logging. It's about making the environment actively hostile to the attacker, even if they manage to get in.
Okay, let's synthesize all of this for you, the listener. We started this deep dive talking about that invisible contract we have with our screens. The landscape has fundamentally shifted.
It really has.
Attackers are no longer just sending suspicious job offers. They are poisoning innocuous web searches for medical equipment to trigger fake panics. They are wrapping AI in autonomous agents to hunt for 0 days while we sleep. And they are quietly exploiting the trusted VPN tunnels of our business partners.
And in response to all of this, the defenders are patching flaws by the hundreds and fundamentally re-architecting global cloud platforms to ensure that one broken sandbox doesn't compromise the entire ecosystem.
Yeah.
The overarching lesson across all these intelligence reports is that trust, whether it's trust to a screen, trust in an identity, or trust in a platform, is the ultimate attack surface.
We spent time unpacking how AI is being used as the attacker scanning for vulnerabilities and orchestrating campaigns from the outside. But I want to leave you with a completely new angle to mull over. Imagine the next evolution of this. What happens when malware starts utilizing large language models locally on your already compromised device? Imagine a virus that silently reads your documents, understands your specific role in a company, and autonomously decides which exact files are valuable enough to quietly exfiltrate or encrypt for maximum leverage.
Wow.
Extortion wouldn't just be automated, it would be highly bespoke and tailored to your specific life.
That is a chilling thought, and unfortunately well within the realm of our current technological trajectory.
It changes the entire paradigm. That invisible contract with reality is broken. Something to think about the next time your screen prompts you for an update.